All right. Thank you very much. It's just easier for me to go back. So let's just start with the official stuff. Jordan, can you say, for the record, as they say, your name and position there at USA?
Sure. So my name is Jordan McLeod, and my position at USA is meteorology instructor. So it's a non-tenure track um, position, but that's I've been there about a year and a half now, actually.
Nice. Very nice. So tell me a little bit about the background work you did with Dr. Shepard about urban meteorology.
Yeah, so we've actually been working on this topic for the better part of several years. It's been maybe up to 5 years now, actually. And it's something that Dr. Shepard has been interested in for a long time, probably all the way back to the 2000s or so. And it's a topic that I became interested in while attending the University of Georgia as a master's student. And by the way, that's where I got my master's degree. But it's just a fascinating topic, I think, to look at how land cover can influence the atmosphere above it. And so I think we've Dr. Shepard and I have been looking at primarily at Atlanta as kind of our test bed for looking at the relationship between thunderstorm activity and the underlying urban land cover interface. But we've recently been expanding to smaller cities, and I'll talk about that a little bit as we go further along. But I'll stop there.
All right, excellent. Yeah, so I think the urban heat island as a concept has really started to work into the lexicon of the general public after all these years. You know, we know that the pavement and the concrete and the bricks and everything heats up more obviously in the cities, and that does have an impact, obviously during the day and especially at night. Um, so let's talk a little bit first about what your research has shown regarding convection and the urban interface, because I hear a lot. We saw a very classical example a few weeks ago where a lot of Virginia in particular was fairly quiet, but there were these convective cells that blew up over suburban DC, over Richmond, over Norfolk, and I was just like, wow, this is eerily good, a good example of this kind of phenomena. So, talk a little bit about what your research has shown in terms of, first of all, before we talk about storm splitting, the genesis zones of convection or thunderstorms.
Yeah, so it's a really fascinating area of research, I think, because, and one thing that we were able to do, this goes back to our 2017 study looking at Atlanta, but basically we look at it from a climatological standpoint. And the way that we do that is we use what's called the MPE data set, or the multi-sensor precipitation estimates data set. And basically, it's a gridded product on about a 4 by 4 kilometer scale. So pretty fine resolution, as you can imagine, that allows us to look at rainfall patterns across a given area. And so as we took a look at, just looking at something as simple as the average the average daily precipitation during the summer season, climatological summer, which we define as June, July, and August, we notice that there's a very interesting pattern that emerges across the Atlanta area in particular. And we suspect, and I've done a little bit of research that looks at other major cities across the Southeast. And we notice in many of those a similar footprint, if you will, basically over and downwind of the metropolitan area. We noticed enhancement of rainfall, convective rainfall. Again, this is just during the summer season. And, basically, we think that one factor, and it's not necessarily the dominant factor at play, but it's certainly playing a role, is the urban heat island effect. And basically, it's allowing, on a given day, and we can talk about some of the ingredients that we think are favorable for the development of urban precipitation. But basically, on a given day, the storms tend to fire up directly over the city and then are pushed downwind by the mean flow, over suburban areas and even into rural areas eventually after that. So it's really a fascinating pattern.
So that kind of makes intuitive sense, right? From a meteorological standpoint. Do you see any kind of favored environmental conditions regarding the wind profile, the wind, not shear, but the wind velocity aloft, like lighter winds, westerly winds, winds, um, you know, 10, 15 knots or less from a particular direction? Is there any other signature that kind of lends itself to helping this phenomenon get started, or conversely, kind of shuts it off?
Yeah, that there is actually, and some of the key research that we've done, I think, has really shown that to be a big factor at play here. And so, at least for the city of Atlanta, we have looked at the climatological 700 millibar wind flow, and so that's that 700 millibar level has been shown to be appropriate for the steering flow, at least during the convective season. Sometimes meteorologists will look at 500 millibars, but we looked at 700 millibars because a previous study, actually by Dr. Shepard and colleagues, I think back in the late 2000s, showed that 700 millibars was the best, most appropriate level to look at for that. And so basically, we found that weaker flow at 700 millibars, especially coming from a westerly direction, anywhere from kind of the southwesterly to northwesterly quadrant, if you will, is most favorable for the development of urban generated convection. And so, basically, it having those weaker wind flows means that you don't have much of a synoptic influence. It basically meant, there's a minimization of any kind of synoptic scale features that could overshadow the more localized mesoscale phenomenon known as what we call the urban rainfall effect, or the URE for short. And so, basically, once you get that weaker flow, it's much more prevalent to see localized convection, and some of that can even be generated by the Atlanta area itself.
Is there any reason, any physical reason why it's from that direction? Let's say from a 240 to a 300-degree wind. Is it just that's kind of the climatological flow a lot of the time? So is it just happenstance, or is there anything else that might be going on with that particular wind vector?
That's an interesting question that maybe, we haven't dived into quite as much to kind of understand. I think that'd be a good future research question, actually, to kind of look at the physical understanding or reasoning behind why that's the case. I do know that I'm thinking back to a figure in one of our papers. I believe it was the most recent paper in 2022 with Dr. Shepard. Basically, we found that if you look at the 500 millibar pattern, that you had to get a favorable, if you were to composite all the days that had an urban rainfall signature, you would have higher than normal heights over the northeastern United States and lower than normal heights over the central plains. And so you can kind of imagine that would be, maybe a little bit of troughiness
Hmm.
in the central plains and more ridging in the eastern U.S. and the eastern seaboard. And so that is a flow pattern that is prevalent for generating the urban generated precipitation. But to kind of answer your question a little more directly, I'm not exactly sure that we know why exactly certain flow patterns are directly connected with urban generated precipitation. Although I'll go back to kind of piggyback off the previous answer I gave, that having that weaker flow aloft, it basically serves as a signal for that reduced synoptic effect. And so we don't want to have fronts in the area. We don't want to have a lot of outflow boundaries from other thunderstorms that can generate convection. We want to have a fairly pristine environment, if you will, for localized convection to occur.
Yeah, that makes a lot of intuitive sense as well. Can you give kind of a ballpark or first order idea of how much of an enhancement that is? Obviously, it's going to be very dependent on any individual situation, but is this a 10% increase? Is it a 50% increase? Is it sometimes doubled, or is the variance just all over the place?
That's an interesting question and a hard one to answer. Something that honestly it'd be interesting to quantify that. Actually, that's actually a really interesting question to think about from a research perspective. But I will say that when we looked at some of these rainfall enhancements, they are statistically significant.
Mm-hmm.
So that's interesting from a statistics perspective. If you look at some of the figures, and I'm thinking back to a pretty basic figure that just shows the average daily precipitation during the summer season across the Atlanta area, that was back in our 2017 paper. You'll look at the scale, and it may not, where the scale goes from, like, I think 0.10 inches to 0.20 inches. And so the variability on a given day is pretty small. It's not again, the one thing that I want to emphasize with urban generated precipitation is it's kind of it kind of operates a little bit in the background. It's not an overwhelming signal on most days that you're just like, wow, that's urban generated precipitation. It kind of it kind of sneaks up on you a little bit on some days, but it's I think and another little nugget I'll throw in there is that we calculated that basically around 8% of an average summer season, it corresponds to urban rainfall days where we, out of the summer season, that we would expect to have some sort of urban generated precipitation. And that is just for the city of Atlanta exclusively. So
just for Atlanta.
Right. So it'd be interesting to calculate that for other cities and see how similar or different they are. But I unfortunately can't give you like a percent, increase.
And that's okay. I just wanted to check, because that's what people are going to ask. And
absolutely,
it's okay to say we don't know yet.
We
That's
really
a perfectly fine answer.
Absolutely.
I don't want to lead the witness, as it were, to saying something you're not comfortable with. It's just one of the things I was curious about. I did not get a chance to read as much as I would have liked to about this concept of bifurcation.
Yes.
Can you talk a little bit about that? Because so many times we hear like, oh, well, the storms just go around my house, or they just split and went around the city. Can you speak to any of that with any confidence?
Yeah, so I'll admit it's not necessarily my area of specialty, but I knew a little enough to make me dangerous, I guess you would say. Basically what happens with a lot of these major urban areas is you get due to the urban heat island effect, you get this heat bubble, or this little miniature localized heat dome, if you will, that we've heard a lot in the news about synoptic scale heat domes that are responsible for heat waves across much of the country. Well, we get kind of a mesoscale heat dome that kind of sets up over a city. And so basically, if a storm has already generated upwind of an area and is approaching that metropolitan area that has that heat dome, sometimes if the conditions are just right, it will actually split and bifurcate around the city and then sort of reform, can oftentimes reform or regenerate downwind of the city. And so that's when we can see that downwind amplification of rainfall, whereas we may not, see as much directly over the city itself. So it's kind of it's an interesting process that is maybe, it's somewhat difficult to capture at times on radar imagery,
Mhm.
but I think it is out there.
What might, even if we don't have a precise physical reason, what may be some of the things there? Are there some kind of bizarre surface convergence areas that have shifted because of let's say, for example, like you're talking about a mesoscale heat dome. Is this something that's just through the boundary layer, I'm guessing?
Yes, I
Okay.
think primarily through the boundary layer. And, basically, I'm trying to remember back to a paper that I saw or read, that basically suggested there could be some sort of urban circulation that develops, almost kind of like a sea breeze circulation in effect, where you get, during the day over the city, you get rising motions, and then on the periphery, over the more rural and suburban areas, you actually can get sinking motions.
Mm,
And then some of that air, so you get kind of a localized area of convergence over and maybe downwind of parts of the city. And we actually found that in our most recent 2022 paper, um, that at 1,000 hectopascals, 1,000 millibars, basically near the surface, that there was enhanced convergence, low level convergence, over the metropolitan area of Atlanta, which could be favorable for the development of urban generated precipitation.
but if there's, all right, walk me back through this, because I'm thinking if there's enhanced convergence over a city, and if there's a storm approaching, that would theoretically, in my head, enhance the opportunity for further development rather than splitting a storm. So what am I missing here?
Yeah, that's a great distinction and an important distinction to make. I think that on most occasions we would typically see, and I've noticed this just sort of anecdotally looking at the radar and kind of picking up on, especially for Atlanta. It's amazing. Atlanta is really a poster child for this URE, this urban rainfall effect. And I've noticed that it seems like a lot of storms, as they approach the Atlanta downtown central business district, they tend to intensify rather than bifurcate. I have seen very few examples of bifurcation around the city of Atlanta. I've seen much more cases of intensification and of those storms over and downwind of the city. So I guess long story short, I'm not exactly sure what conditions are favorable for the enhancement of a storm versus the bifurcation of a storm over a city. I think that is where future research could really come into play.
Got it. But there are probably some kind of solenoidal circulations between the rural and suburban environments with the inner city or the inner urban cores that are playing a role that still need to be investigated further. Would that
Absolutely.
be,
Yeah. That would be a
if I
great
were to
way to.
write that, would that be okay?
Yes, yes. I think that's an
I don't,
excellent way.
I've been misrepresented print more times than I care to imagine. So I want to be sure that I'm representing the science and what your research and the understanding is the best that I can.
No, yeah, that's a great way to summarize it, I think.
Um, is there any evidence, because Atlanta has a little bit of terrain? A lot of people forget that Atlanta isn't on some coastal plain. It's up there and toward the southern end of the Appalachians. Uh, any indication that there's maybe some terrain interacting as well? I mean, yeah, you picked Atlanta because that's where you had the data, obviously. But is there any give it any thought to like, well, we are in a slightly higher elevation here compared to surrounding areas in South Georgia and Southern Alabama. Any consideration in elevation there, the generation of thunderstorms we know happens in, the elevated convection, that kind of stuff.
Right.
Any considerations there?
Yes, yes. And as if you go back and look at that figure that I've referenced several times about the in the 2017 study, you'll notice that there is an area of very enhanced precipitation the further north and east you go towards the Appalachians, towards Lake Lanier, as you
Mhm.
get towards Lake Lanier, northeast of the city, and even further to the northeast than that, you'll notice that precipitation really ramps up compared to downtown Atlanta. And so there is most definitely a topographic influence that is at play there, and we certainly don't want to forget about that because it's operating. It's sometimes at the same time that the urban rainfall effect is operating, and so that's really what makes this a little bit challenging is that you've got different processes at work on different scales at the same time. And so that can really make this a challenge.
Is this the one that was in Frontiers in Environmental Science?
I'm actually referencing the 2017 paper, the urban climate. It was in urban climate.
Okay. All right. I need to go back and double check because, yeah, because if I have any cool diagrams, I'd like to. Oh, there it is in urban climate. Yeah. And I don't know what, and if you don't know, that's fine. But if there's anything in here that I'm allowed to share, do you know? Do you even know if I'm
I,
allowed?
I, oh, that's a good question. I think you're allowed to, I think as long as it's an open access paper, I think it's okay to share if I'm not mistaken, but
Okay. I
I
won't hold
may,
you to it. I just didn't know
yeah,
if you
I'm
know,
not 100% sure on that, but I
because I see
think
a couple of the wind roses and things like that. So,
yes, yes. And actually, come to think of it, if you do want to use, and that's certainly fine with me, there's an updated version in the 2022 paper, The Frontiers, figure 1A and B, that's very similar to figure 1 in the 2017 paper, but it just has a little bit more data to it.
all right.
So
And that's
um,
that's also in urban, or you said that was in.
that one is in Frontiers, the
Okay.
more recent paper.
All right. All right. Excellent.
Hmm.
Okay, I think that's all I need. That's wonderful, Jordan. Thank you so
Oh,
very
you're
much.
welcome.
I
It was a
appreciate it.
pleasure talking with you.
And I'm sure you interact with Marshall. Marshall is just wonderful. I kind of know him professionally, and love to amplify his voice wherever he can. But I definitely want to reach out to you because I know he's so busy.
He is, yeah. It's especially with the semester upcoming
Oh my
start.
gosh,
Yeah,
he is
he's a busy fella.
is just swamped all the time. So please say hi to him on my behalf next time you chat with him.
I will,
Um,
absolutely.
and I'll try to get something written up, and I will share the article with you once it goes live sometime over the weekend.
That sounds great, Sean. I really appreciate it. And
Absolutely, there's a lot of questions out there, so that's one of the things I'm fortunate in this new venture that I'm doing that I'm able to do some of these things. So thank you.
absolutely. Well, I appreciate you highlighting the research, and hopefully it will answer some folks' questions that they have.
That's always the hope. And if anything else strikes you, email me right away, and I'll try to get it in.
That sounds great.
All right,
Okay.
Jordan,
Talk to you
take
later.
care.
All right. You
Have a good
too.
weekend.
You too. Bye bye.
Bye bye.